Hello everyone, so welcome back to the online class of class 9 science, the physics part. So today we'll be learning the equations of motion. That means chapter number 8, motion chapter. We'll be learning equations of motion. So in this part we have three equations of motion. These are v equal to u plus at. This is number 1. Then number 2, s equal to ut plus half at square, and number 3, 2as equal to v square minus u square. So here in all these equations they have their general names. These symbols have the general meaning. V is the final velocity, u is the initial velocity, a is acceleration, t is time, and s is the displacement. Now all these three equations of motion have their different name. First of all, the first equation of motion is known as velocity time relation. First one is the velocity time relation. Second one is the displacement. Second one is the position time relation, and the third one is the position velocity relation. So here in these equations of motion we have to derive this and this equation, means we have to find it out. So you can write this down, pause the video and write it down. So first we will derive the velocity time relation. So I'm just rubbing it up. So first one we will be doing is the velocity time relation. I will pause the video in between so that I can save some time. Now if you remember the uniform motion curve, that means in the previous video when we were learning the velocity time relations, means when we were learning about the when we were learning about the velocity time graph, there we learned that for uniform motion the graph was something like this. This was our graph that we learned. Here was the origin, this was our time, and this is our velocity. So this graph we learned in the velocity time part. So this is the velocity time curve or graph for a uniform motion. And there in this part I explained you that if we take any 2 points on this graph from here to here, that means let it be point A and let it be point B. That means if an object moves from A to P, we have to find the area or the part between these two. Means we have to find this part. We have to find it out. So when we will find the velocity time relation, we will be using only this part. Means from A to B, only this much part we will take. So if you see here like this is a trapezium. That means if I draw this shape separately, if you ignore this part from here to here, if you ignore this part, this is a trapezium. We will be using this part in the finding, in the derivation. So we don't need this whole part, we don't need this whole graph, we only need this part. So for that we can shift this y-axis onto this point, onto point A. I am drawing it here. This was our y-axis, this is our x-axis, and here I am shifting this point A to here, means I am taking this much part of the graph. This is the point B, this is the point A. this much part I have taken up to here. That means I am taking only the trapezium from that part, this one. So this is our origin, and this one we can give it any name, like I am giving here C, A, B, C. So this much we will be using to find the velocity time relation. We don't need this part anymore. Now here in this graph, if an object moves from one point to another, if it is, this is the starting point, this is the finishing point, last point, then A is the initial point, B is the final point. So here this is initial point, that means this one, this much is taken as initial velocity u. B is the final point, this much is the final velocity v. So we will use these terms, we will use this, and from O to C, since this is the time axis, this is the time taken by the object t. So I am just rubbing it here, from here I am rubbing it out. We will be writing those separately. This is our point C. Now we will use it here. So we have to write, we will assume some initial variables. Let OA equal to U, BC V, and OC equal to T. And we can do one more thing. If I divide this part, means if I put a perpendicular on BC from A, that means I am dividing this part using a perpendicular. So I can name it as point D, this one point as D. So if you see here, this trapezium has been divided into two parts. One is the triangle and one is the rectangle. ABD is the triangle, OADC is the rectangle, and BC has been divided into two parts, DC and DB. And we know in a rectangle opposite sides are equal in length. So if this side is U, from D to C this much will also be U. So here we can write BC equal to BD plus DC. We have divided it. That means as if total was V, this whole from B to C, this was V, and if this much is U, this much will also be U. So here we can write DC U, opposite sides of a rectangle. Also OC will be equal to AD, opposite sides of the rectangle are equal. So AD is equal to T. This much things we have to first assume, this much things we have to take. Now we will use the formula for acceleration. We know the formula for acceleration is change in velocity by time. So A equal to change in velocity by time. So here in this part, the change in velocity is BC minus DC. That means this much is the change. Like for example, if I have a line, I have a piece of wood, one long piece of wood, one short piece of wood. If I want to know how much this second piece is longer, then what we will do? We will measure these two equally. So this much and this much will be equal, and this much will be the extra part, this much will be the length. So that will be the change. So here the change is BD. So change in velocity is BD, and the time is OC. So here it is BD, and here from here we can get BD, we can write BC minus DC, and we have the OC as time. So if we take all the initial values, if we substitute these values, let it be A, which was A, from here gives BC. BC is V, DC. DC is U, OC. OC is T. Here is OC, T. Here we have written. So here we get the final equation. If we multiply these two, we get it as AT equal to V minus U, or we can write V equal to U plus AT. So this is our first equation of motion, the first equation of motion. So you can pause the video and write it down. Okay, so this much only for today. This one, when you have to do this solution, you have to solve this, you have to start from here. You have to write everything from the let up to here, and also you have to make this graph. Means this much has to be drawn, putting all the required points. All the points should be labeled properly. Thank you.